Good afternoon. Today we're going to talk about applying machine learning tools for urban transport. Dwellers of modern megapolises encounter traffic problems quite often, and authorities need tools to optimize traffic and the public transit in the city. So this slide shows the main challenges for city transport, inefficient transport infrastructure, so both for public transit and for personal cars, environmental problem with pollution, problems of effective location of commercial infrastructure sites such as shops, shopping centers, bridges, urban dwelling areas. And we can use a transport system model as a way to solve it that reflects not only the current state of the transport network, but also allows predicting the impact of managerial activities. At present, such transport models are not only used by authorities to make such some, governance decisions, but they're also used by commercial organizations to improve business efficiency and providing better services to users. For instance, in Russia, such services, 2GIS or Yandex Maps are doing that, and they focus on creating GIS systems that allow assessing the current load on the transport system in the city to predict traffic jams and gridlocks. But unfortunately, the algorithms developed by companies like that are kept secret, and each group of researchers has to do the work from the start. Of course, some of such information is public, and we can reuse that. Transport models have been studied for quite a long time, and there are different approaches to build them. For instance, fluid mechanics, analogies, machine learning tools, and others. But the choice of technology depends on the purpose of modeling and on the source data. This slide shows the classification model depending on the input situation. Transport models can be created based on social economic information and some ideas about its impact on the transport systems. What we mean by social economic information is the information about where people live, where they work, about the gravitational points where they go during the day, and the purposes of their movements. And so in this case, the popular approach is to build models based on fluid mechanic analogies. Another approach is to use the traffic monitoring systems to create monitoring. As part of this approach, we proceed not from some ideas where people live, but we just observe traffic flows and try to identify the patterns and laws of behavior. It's done with different level of detail depending on the task at hand. It could be done at a micro, meso, and macro level, at the level of the whole city, or maybe an intersection, just a small part of the road. Also, this modeling can be done in different time intervals. You can assess the current situation, short-term, mid-term, and long-term predictions. The model can be described with different level of detail. It can contain information about the transport network, only about topology, the roads, intersections, or forks, but it also contains information about car and people flows. Of course, it's going to be difficult, and it needs to describe more aspects. Also, a transport system model can handle different random events, and then it's called stochastic. It could also be static and dynamic. To build a dynamic model, agents are used. Talking about the data that we're working with to build models, they have a spatial character, and they need to different methods need to be applied.
First of all, we need to have quite a lot of volume, so we work with big data, as we can assume, most often partially observable both in time and place and in space and spatial correlations. Like I said, this traffic flow characteristics contain information about the topology of the road network, about the traffic rules, about pedestrian crossings, and various constructions. The second component is about density of traffic that is used in this network. So one of the problems of transport modeling would be identification of the features of the traffic, like intensity, density, and speed. These features can be measured with the use of the algorithms using social economic data, and they can be recreated with the use of the monitoring data. Such algorithms are heavily utilized in the work that we do. Unfortunately, the current state of affairs cannot allow us to monitor all of the transport and traffic flows. We can only do it partially. And in order to do that, and in order to use monitoring systems, we need to have different data. For example, for intensity and in density, we just need to have several sections of roads analysis. With speed, we can monitor individual vehicles. In our work, we address speed of different vehicles based upon different models. And these can be used for creating the traffic flow chart of the city, which I mentioned previously, and also it can be used to address various advertising services for the general public, like placing out-of-house ads. One of the key problems that involve storage and computing power address the following state-of-the-art method, that is geographically weighted regression. Geographically weighted regression, GWR, of the main components. I would like to say a few words about them and explain how this traffic speed map really works with this model taken into account. Current research prove that the features of the transport network, like for example the width of lanes, different turnings and curves, the quality of pavement, really affect the velocity, the speed of traffic. The same parameters may differently affect traffic in different parts of a settlement, like town or city. Having a curve may reduce the velocity and it may also increase it. Having a pedestrian crossing and having a habit of jaywalking may all influence the situation with the speed of the traffic, and they really do impact the situation with the traffic in different areas. Therefore, the GWR method, geographically weighted regression, is the most relevant principle that can be used here, because it builds regression models with the geographically connected areas. We're using a function which would regulate the components taken into account, and it would regulate the proximity with having bigger weights to close points and lighter weights to far distant points, which would have to monitor. Thus, we can select an appropriate function and take into account the points that are of big interest to us. There are different methods that we can use. We just need to select appropriate parameters of the function. And it's important to select a metric of the distance. The best results would be distances, not just direct distances, but with the entire net taken for analysis. This method suits the traffic velocity analysis very well, and it can be used also for the commodity prices analysis, density of population analysis of different parts of the city, etc. Also, the Kriging methods can be mentioned here, but I wouldn't want to get into detail about them. As we find out more subtleties, neural networks can help us figure the situation out with them, as these neural networks are becoming more omnipresent. We may be easily finding out the value of each particular factor, but here we are working with a black box, and some non-trivial dependencies may affect the situation. And as we predict the speed of traffic, different layers model may be found very useful here. And as we take into account the number of lanes, the length of a pedestrian crossing, different curves, we also need to measure the geographical coordinates of vehicles. We are currently learning new configurations of neural networks, like, for example, convolutional networks, but these studies are currently at inception stage. Whatever machine learning method we use here, one of the biggest tasks would be finding the right values for learning. I hope this topic was interesting for you. If you find it interesting, please contact me by my email, and I welcome your questions. Ksenia, thank you very much. I was very interested about your presentation, and as I was listening to this presentation of yours, I just started thinking, is it just pure theory that you are discussing, or you have been involved with practical contacts with the local administration and traffic police in Novosibirsk, and you tried to apply that? Well, we have a very lengthy path of working with the transport models. We have carried out research where we use different types of approach, and some of them have already been implemented in the city of Novosibirsk, and different models have been used, and we have found them useful. For example, the traffic of heavy cargo transportation, the trucks transportation. Like, for example, when we were studying issues of introducing new bridges in the city of Novosibirsk, with the geographically weighted methods, we apply them in real life, and we use data supplied by the city council of Novosibirsk. But We just use them for learning purposes. In practice, we have not used them much yet. Well, I understand, it's clear, but since you've been tackling this public transport situation, you said that you would learn how the curves and the amount of people on bus stops would affect the situation with traffic. We are not taking into account subway or rapid transit systems, because you only just applied your studies to the buses. No, I didn't do that. We only just used the buses for analysis. What were the means of transport? Buses, trolley buses, trams? Which are the more prospective? Well, I think the more prospective ones are long-distance transport, like trolley buses. Trolley buses allow us to unload the traffic roads, but so far we have not been improving situation with the public transport in this city. All the studies really show that the trams and trolley buses are most heavily loaded. And you said that you just need to make more spacious buses and trolley buses. And as for the route itself, is it the longer route which is more efficient or a shorter one? I wouldn't answer this. It would be very difficult for me to say which is best, a long route or a short route. I think it's when the transfer area is properly organized, because this is what affects the situation. People wouldn't want to use the public transport because the transfer requires quite a lot of effort. For example, when we make a change from a bus to another one, or just physically, it's very clumsily done. It's inconvenient, and that's what affects the situation. I see. Thank you very much. And I think all of your learnings will definitely be used by public transport in our cities, and public transport will become more useful and accessible, and it will definitely entail the situation